Good morning, everyone, and welcome to the talk. My name is Gurjeet Singh. I work for Enterprise DB. I have worked with Enterprise DB for about 7 years now, over 7 years, in various capacities: internals developer, consultant, trainer, uh, pretty much everything that Enterprise DB does. I think except for support. I've never been in support. Uh, but apart from that, I have touched almost every part of our company. And this talk is going to be about Postgres. Even though I represent Enterprise DB in the conference, this is purely about Postgres. There are some parts of Enterprise DB that are of interest to you guys even within this talk, but I'll keep my focus on Postgres primarily. So the talk here, or the agenda here, is to prove that Postgres is ready for whatever workload that you are ready to put on. Your enterprise workloads, whatever you are using, Oracle, DB2, they can be replaced with Postgres, provided you are ready to do that. The point is, Postgres is ready to do that. And the projection we'll have over here is about a platform. Postgres has become a platform. It's not just a database anymore. It can do a lot many things than just creating a table, an index, or a view. It has a lot more capabilities that you might not be aware of. And even if you have been using Postgres for a long time, they might be like, my hopes are from this talk you'll be exposed to some things that you may go back and explore more about and try to use them in your projects. So here we go. Enterprise DB, Gurjeet Singh, you already know that. So this talk will have two perspectives. One, from the perspective of the developer. As a developer, what do you look forward to? And as a manager, why would you choose Postgres, and what are the points that you can look up to make that choice as opposed to any other database, say Oracle or DB2. So from a developer's perspective, there are quite a few things that a developer cares about. The license model, the reliability of the database, the security that it provides, the features, how they can be exploited, extensibility, not just what's provided stock in the database, in the product, but how you can make it work better to your advantage. And then, of course, an RDBMS is all about performance. If you do not have performance or decent enough performance, you won't even consider using it in your projects. And then one of the other aspects is diagnosability, that a developer looks up to, saying, if something goes wrong, how can I diagnose problems? Specifically, performance problems are what a database should provide to be diagnosable. So license. Postgres has a BSD-like license. It's not exactly BSD. It started with BSD license, but when BSD license changed, it removed one of the terms or maybe added one term, but Postgres team decided to keep the original license, and now it is called Postgres SQL license. So it's almost exactly the same as BSD license, but a bit more liberal, I think. So what does that give you? And how is it different from any other license? So it's very different from GPL. That's the most famous license out there that everybody, the first person coming to open source knows about or learns about is GPL. Okay, my software is GPL, so you can use it. But BSD is much better than GPL because GPL restricts the use of the software. You can use it for free, no license cost, etc. But the moment you try to modify and redistribute that code, you will have to open source that code. But BSD says, I do not care what you do with it. Rebrand it, resell it, modify it, and you don't have to pay anything to the original license holder. So this gives a lot of flexibility to the vendors, to the providers, to supporters of Postgres. Like Enterprise DB, we have a version of Postgres that is in a way serving our customer base. Similarly, there have been a lot of other projects that took Postgres as the base because it's a solid database, and then they improved it, provided some additional functionalities. So that gives the freedom to the developers also, not just the internals developers, but the developers who are using the database, that they can explore the code, they can look at the code, understand the database internals, exploit those functionalities, and make better use of them. The other thing that paid or commercial databases restrict you from is they give you a toy database version that has lesser feature set. You use this to develop your application, but when you want to actually deploy it in production, sell it, you'll have to buy licenses for that, and that's much more expensive than what I'm giving you. With Postgres, that just goes out of the window. You do not have to care about what I'm going to ship versus what I'm going to develop against. Everything is the same. With commercial RDBMS, you also have the restriction that even if the database has been running in production for 7 years, 8 years on the same hardware, the moment you try to change that hardware, upgrade that hardware, now you have to contact the commercial vendor saying, I upgraded the number of CPUs, I upgraded the RAM on my, and what do I pay now? So that is not a concern anymore with Postgres. Reliability perspective, the only thing that matters in RDBMS world is ACID compliance. Is an RDBMS ACID compliant or not? ACID stands for atomicity, consistency, isolation, and durability of transactions. So a database that is compliant with ACID guarantees that the transactions will be atomic. Either everything will be committed or nothing will be committed. They will be consistent. That means after a transaction has been committed, the database will move from one consistent state to the other. That means foreign key relationships, primary key constraints, everything will be consistent. They will be isolated in the sense one transaction cannot see the data modified by the other transaction until they are committed. And durable means once a transaction has been committed, even if the database crashes, it's on disk, it's durable, it can be recovered from, it can be again brought back to life. And you can make further decisions based on durable transactions. It has constraints, all the basic types of constraints, primary key, foreign key, and check constraints. We will see also additional features like exclusion constraints. I'll describe those in the later slides. So it has why are they, these are not just features, these are features that provide you reliability. You cannot corrupt your data, logically corrupt, not physically, logically corrupt your data by not following or not implementing your foreign keys or primary keys. So if you use those, your data will be always consistent. Now with the latest version, Postgres comes with data page checksums. It detects your physical corruption. Until version 9.2, that wasn't the case. That means database Postgres always cared about logical corruption. It won't let you corrupt your database logically. It won't let you input values into a primary key column where there are duplicate values. But with this version, you have data page checksums, so which guarantee that if your hardware, if your data disk controller or your RAM is corrupted, they have modified the data, then Postgres can detect that corruption and let you know before it's too late. From security perspective, Postgres has pretty extensive tool set. So starting from the objects, you can grant and revoke permissions on per object basis on tables, indexes, tables, views, and functions. Beyond that, it also supports permissions for the individual columns. You can specify which columns a user can have access to. Beyond that, SSL connections is one of the basic requirements, I would say, if you want to have a 3-tier N-level architecture where clients and databases live on separate machines, communicate over the network, they need to communicate securely, safely, that the data cannot be stolen. So SSL connections is one of the primary features, I would say, that Postgres has, and you should leverage it without any question. LDAP and Radius, these are the authentication methods. So if you do not want to deploy the same users over and over again for your database, for your emails, etc., you can configure LDAP and Radius. There are many other GSS API authentication methods which you can use to create or represent your user within your organization, outside your database, and map them to the database users. So as I said, Postgres is a platform. It's not just a database anymore. And over the next few slides, I'll make a case for that. So it has a vast feature set, and it is ever increasing, ever expanding. So there's a web page on PostgreSQL website that lists all the features, and I would still argue that they are not all the features, even if that is maintained by the community. There are probably many things that are not listed there. But even those are like awesome. So I'll just cover a few features. As I said, covering all the features, describing them would take a whole day at least. Uh, so just a few, just enough to make you curious that, okay, this database can do this. Yes, maybe I can use it in my next project, or maybe I can take this as a point in consideration when I'm choosing my next database for the project. So common table expressions is like a function or a macro that you would use in your applications, wherein you can reuse that piece of code. So common table expressions are like that, small pieces of queries within a larger query, and you can use them in this larger query to repeatedly get the same results. And they also support recursive evaluation, in a sense. One common table expression can reference itself and produce the results repeatedly. So just to give you an example or a background, how it connects, Oracle has a feature called connect by. Most of you guys would have used it. Okay. So this actually, CTE is a SQL standard way of implementing those and much more than that. Data types. Postgres has a lot of data types, almost everything that you might want to use, and even if that isn't sufficient, you can create your own. And you can extend Postgres, and we'll talk about that in extensibility part. So many advantages of using built-in data types rather than having to extract text data from the columns and do manipulation or casting on your data within your application. So this gives you a lot of flexibility, in the sense you do not have to extract the data, compute on it in your application, and then put the results back. You can do the computation within the database itself. So one thing I would like to note, which I like very much about Postgres, is it does not have nvarchar or any nationalized thing support, or data type, I would say. It doesn't have that data type, any variations of nchar or nvarchar, because the base data types, the char, varchar, text, all the text data types support Unicode characters, Unicode storage, Unicode values, using various encodings. You can choose what encoding do you want, UTF encoding, that's like on-disk layout that you want, but otherwise you can store pretty much every kind of character in these character data types. So you do not have to choose at the time of creation of the application, do you want to do char calculations or char storage or nchar storage? So it's always going to support all types of data. Boolean is a first-class data type. I'm trying to contrast this to some commercial databases. So Oracle is a prime example here that says you can do Boolean comparisons within your queries. Where clauses are an example, right? Where you say where x is greater than y, what's the result? It's Boolean. So that means it is capable of handling Booleans, but it cannot store Booleans. But Postgres has Boolean as a first-class data type. And you can store that, manipulate that within the database. You do not have to store zeros and ones or bits or anything else and then perform the calculations in that. It has support for bits and bit strings. So if you have binary data or some kind of mask that you want to store, so you can store directly in the database and do that bit masking within the database instead of having to extract that an integer from the database, do a masking on that within your application. It has support for money data type. It's very old data type, very basic. So the case for money data type is, you would say, yeah, I can always store money in my float data type or double data type. But the problem is there are rounding errors. Whenever you perform a calculation using float or double, multiplication, addition, you will have rounding errors. But money data type prevents those things. Then there is storage of binary data. If you have images, any kind of recordings, any x-rays you want to store, anything, that can be stored within the database. Interval time data type. This is again one kind of differentiator. There are timestamps in the other databases, but interval is one of the unique data types that Postgres supports. So difference between two timestamps is not a number. Other databases, other applications might have you believe that the result is a number that represents maybe number of days, number of seconds, number of microseconds or milliseconds. But Postgres has a unique data type for results of that kind. Those are intervals. And you can use that data type to add value or perform calculations using timestamps. You can say today plus 7 days from now, what's going to be the result? So you can say, you can perform those calculations. It has enumerated data types. Enumerations are something that you use in your application. You do not expect your database to provide that. You would store strings or numbers and then map them to your enumerated data type in your application. But Postgres provides you enums as the first class data type. So it stores them as integers, numbers on the disk, but from the application perspective, they are string literals. So you can create a data type called week or a weekday, and you can store Sunday, Monday, Tuesday, perform calculation, is Sunday less than Monday, is Sunday greater than Saturday. So depending upon your settings, you would get proper results on that. And it has geometry types, point, line, segment, polygon. So you can perform calculation and you can store that data in your database as it is. You do not have to store, to represent a square, you do not have to create a 4-column table and then extract the data and do calculation. And another unique data type, network address. To store a network address is quite complicated. You can simply store it as varchar or text, but to finally perform a calculation based on that, to get it in your application and then say, does this network address match within this class A address or class B address, this network, does it belong there? You can perform all of those calculations within this Postgres database. So INET address, the data types can store IPv4, IPv6 addresses. CIDR is another representation of those addresses, and then you can also store MAC addresses, your network card addresses. So these are just examples that I'm giving you. There are many more things that you can do. One unique development within the last few releases is range types. 9.2, I think, came with the range types. You would say, what's the big deal? But the problem is it's solving a problem that you would have to otherwise solve in your application and solve it over and over again in every new interface that you develop for your database. You wrote an application against the same schema in Python, you would do something, and then you'd do something else, write a Java application for your mobile or web, you would have to do the same calculation, talk to the database. So instead of having to do all of that, Postgres provides you that within the database. You do not have to extract the data and perform a calculation. You get the results, not the data. It has composite types. So range types will cover, again, in exclusion constraints because it's a very solid feature that you can use for multiple users. We'll cover just a few examples. Composite types. So you can compose bigger data types based on your basic fundamental data type. So you can create a type called person that has an integer and a varchar representing a name and an age. And then you can create an operator that says create person plus number 1 represents increasing the person's age. So result would be a person type again that increases the age of the person by 1. So you can create composite types and you can embed person type into employee type and use employee type to create your HR database. So that's what Postgres allows you to do instead of having to store an array in varchar representing the age, salary, etc. within the database. And every type that you create and every type that comes built in with Postgres has automatically a corresponding array type. Arrays are your programming language features, right? Like why would a database have arrays? So that's the case for declaring Postgres as a platform rather than just a database. So you can perform array calculations and array manipulations within the database. These are some of the data types that are of interest for the recent NoSQL adopters or the web services or web application developers who want to store key values, schema-less storage, etc. Right? So Hstore is a very old data type. It's not new, but it has been underutilized, underpublicized, I would say. So Hstore has the ability to store key value pairs. You do not have to predefine the schema, what you're going to store there, but it has the additional capability of creating indexes on top of that. So we'll cover that in different types of indexes that you can use to index your Hstore and speed up the access. Then there are new data types called JSON, that's very recent addition, and a bit older XML implementation. So Postgres has these data types built in, and not just data types, but the functions to manipulate those, extract data from those. Just to go on to, as I said, like there are many things to cover in Postgres features. I'm not even touching the streaming replication or the hot standby, what you can do with that. So just like the fleeting mention of all these things. It has streaming replication, that means you can have a standby, warm standby if you want. It has hot standby feature, that means you can convert that hot standby warm standby into a hot standby and do load balancing for the read-only queries. It has per transaction synchronous replication. So it has synchronous replication. That means every time an application issues commit, the commit response will not be given to the client until it has been acknowledged by one of the streaming replication clients or replicas. So what that gives you is that guarantee that even if the database, the primary database crashes, even the disk is burnt, your replica has that transaction committed on the disk. So, and that is synchronous replication. Many other databases might have that, but the unique feature in Postgres is per transaction control. So with every transaction, when you start it, you can specify, do I want this transaction to be synchronous or not? So you can grade your transactions as a this data that I'm manipulating in this transaction is not very important. I can forego the synchronicity. But that other transaction that I'm using has banking transaction or banking details going in modified. That I want to be synchronously committed before my client gets the commit response back. Truly serializable transactions, Postgres had serializable transactions before, but with 9.2 we have SSI, a specific implementation of serializable transaction that gives it true serializability. And very few databases in the world have that, can claim that they have serializable transactions. Listen notify, again a platform feature, not a database feature. Listen notify is asynchronous notification of clients to communicate with each other. What applications might have to, two instances of application will have to do is modify some data in the database, tell the other application over a JBoss or whatever bus they use or any other kind of communication to let them know the data has changed and you may be interested in that. Or the person who's trying to look for the change will repeatedly poll that every second, every minute, whatever is suitable for that application. But Postgres gives you the capability, a client would connect and register for listen notifications. So they would say, listen for this event, and whenever the other application modifies the data, a trigger, even a trigger or an application can send out that notification, and all those clients who are listening for that event will get notified by the database. No other communication mechanism necessary. It has like basic features like triggers, exclusion constraints. Exclusion constraints are generalization of your unique constraints. Unique constraints simply say, if there is any duplicate value within this column or this set of columns, it's an error. But exclusion constraints allow you to define what that uniqueness means. How do you define uniqueness? How do you want to define exclusion, overlap of data types? So combining exclusion constraint with those range data types, I can simply give you an example. You do not ever want to double book a room. So if you're providing a reservation system, you would have a room booked for say 5 days. Another client comes in, asks for that room. In your application, you'll have to try to figure out, am I double booking this room for a specific time or not? But with this feature, exclusion constraints and range data types, you can offload that responsibility directly to the database. Application simply says, I want room from date A to date B, insert that row, and the application, the database would send out an error saying, you are performing an overlap, I won't allow you to do that. So you do not have to do anything in the application. Window functions, a SQL standard way of providing like windows over result set of your queries. Function overloading, you can have functions by the same name but accepting different data types. Operator overloading, something I think no other database has. As I said, you can define a type person, you can define an operator plus that takes a person and number one, and that the result would be a person data type again whose age has been increased by 1, and you can perform further manipulation, store that. So operator overloading is another differentiator. Full text search, something that you do every day, Google, Bing, or whatever you are using these days. Full text search is, I think, one of the basic necessities of any application today. If you are storing documents, you want to search those documents for specific keywords and rank them based on that. So that is built into the database here. Large objects up to 4 terabytes until version 9.2, Postgres supported 2 gigabyte storage for large objects like any size. But with 9.3, the limit has been increased to 4 terabytes, so you do not even have to think of storing database data into your file systems separately from your database. If you want, you can shove them into the database if you want. There are pros and cons to doing that. And then the recent addition of materialized views. This pushes database Postgres more closer to the BI world, the data warehousing world, where you have automatically refreshing materialized views or periodically refreshing. And even though Postgres doesn't have all those fancy features yet, but we are getting to it. Another key differentiator, not one, not two, but n number of programming languages to create your stored procedures, functions, and triggers. So this is another differentiator. That means you can create an extension, a programming language that you want to use, and install that into Postgres and start creating functions based on that. So PLv8 is another recent development that I'm excited about because the whole world seems to be moving to JavaScript, server side, client side, and all kinds of stuff. Hardware being controlled by JavaScript. So this is another exciting part of Postgres, that it has PLv8. It has that capability. No other database allows you to create new programming languages for it. Toast, the oversized attribute storage techniques. This is an automatic, transparent, completely invisible feature to you. You will never even know that it is there unless you read about it or somebody tells you about it. What it says is, if a varchar type or any variable length data type crosses a certain threshold, it will be broken down into pieces, chunks, optionally compressed, and put away aside from the main table. So main table will not be bloated because you are inserting 1 gigabyte or 10 gigabyte values into the columns. So this is completely automatic, completely transparent, and this also helps boost performance because your table scans will be faster because your table is not bloated anymore. So now we are moving on from feature descriptions and feature differentiators to performance. So even the performance can never be a differentiator. You can simply compare the performance. You cannot say that performance X is a differentiator. So performance is a measure. And Postgres, the performance has increased by leaps and bounds, and it has always been good. But it's only increasing by additional features that help increase or improve the performance of your applications. So the cost-based optimizer is one of the key differentiators of Postgres versus any other open source database. Commercial databases have hundreds of engineers working on just one component, query optimizer. But with Postgres, I won't say the few, but it has competent enough cost-based optimizer that you can check out your commercial database and put this in and still expect to get a great performance. Index-only scans is a recent addition that says if your query touches only the columns that are stored in an index, I will use that index instead of having to go fetch the table data also. This sounds very simple, very basic, right? Why won't you do that from the beginning? But it was a tricky thing to implement, but now we have it. Synchronized sequential scans. So this again helps even if your application is not using indexes and you are performing some kind of reporting, huge number of clients performing scans on the same table. Synchronized sequential scan helps you boost performance by not requiring to read from the disk the same blocks that have already been read by another client. So say client 1 has processed a table 50% through. Another client comes in and says, I want to scan the same table again. Instead of starting from 0th block, first block of the table, it will start from the same block where the other client is already reading. So it means that it is optimizing the database access, disk access, by not reading those blocks again. And they are working in lockstep to improve the performance, read the same blocks of data. Once the first client is done with the 100% of the table read, the second client that has started from halfway through will turn around and start from the beginning and read the first half of the table now. So now you do not have to read the table twice just because you had two clients reading the tables. To improve performance, you have table partitioning. That helps you reduce the size of the tables. Smaller tables means smaller indexes. That means you can optimize the queries. It has also additional features that go with table partitioning that help you improve performance by not having to scan the whole big table, but just the smaller partitions and improve the performance. Unlock tables is a new feature again that says this table is only important to me for this like it's kind of a transient data for me. And if the server crashes, the database server crashes, I'm going to rebuild this table from scratch again the next time database comes online. That means I do not want this table to be transactionally logged. The X log or the wall log that we always hear about in Postgres is an overhead that can be avoided, and for certain use cases. An unlocked table is that use case. So if you are storing in your web application the cookies, etc., they are going to be rebuilt anyway the next time client connects after a whole, let's say, database restart. You can use unlocked tables to do that. Partial indexes, another differentiator, I would say. Instead of creating an index on the whole table or whole 10 million rows, if you know that only a certain subset of my rows have this particular condition that my queries are also going to be interested in, say where the salary is more than $90,000. That means there are only a few people in the company who have that kind of salary, let's say. So you would create a partial index that says create index XYZ regular definition where salary is greater than 90,000. What that does is any query that comes with that query, with that condition where salary is greater than 90,000, that will match this index exactly, and it will use that index. Because it's a smaller index, it will perform faster than any other index that's spanning the whole table. So it will use that index and your queries will be faster for that reason. Postgres supports many types of indexes, and you would say, why would you need that? Why isn't B-tree index just enough for every use case? It is not. Everybody knows that. Like one hammer cannot, like, every problem is not a nail that you can like use a single hammer to solve. You have different kinds of problems. They have different use cases, different access patterns. For those, you need different kinds of indexes to optimize their specific use cases. So hash indexes are like something that you would already expect in a database. But in addition to those, Postgres has gin, gist, knn gist, sp gist, and these are all specifically usable in certain use cases. And PostGIS, like when you're creating your own custom data types, that's when you want to use these indexes to speed up their performance, their query. Types of join strategies, not much of a differentiator, but just to say that it is equal to your enterprise database that you must be already using, or it is better than the open source database you are using. So it has nested loop joins, a brain dead way of joining two tables. It has hash joins. It has sort merge joins to sort the two sides of the join and then merge them. It has bitmap index scan. So this allows you to use multiple indexes to scan the same table. So if you have two conditions, two where clauses on a table, so Postgres can scan two indexes corresponding to those two where clauses, create a bitmap of the rows that match, and join those based on whatever your where condition was. If it was X and Y, then it will perform a bitmap and. If it was X or Y, it will say bitmap or and give your result. So that's an in-memory bitmap representation of your index scans. So that gives you the ability to use multiple indexes for single scan, not just one scan and one index for that. For exists and not exists query, you have semi-joins and anti-joins. You won't see them in your plans or in your queries. You won't say that, okay, A anti-join B. They are actually a way of producing the results faster based on the query type you're using. So if you are thinking of using NoSQL databases, I would highly recommend going through these slides done by Christoph Pettus just a few months ago. And towards the end of that presentation, he showed that Postgres is as capable or even better than your MongoDB at the same use cases, in the same scenarios for the same data types. So create JSON data types, create HStore, create indexes on that, and see who performs better. So Postgres outperforms these by multiples, if not an order of magnitude. So I would highly recommend going through this presentation and see the numbers actually on your own and the test cases they developed for that. when something goes wrong or something's not working as expected, you want to be able to dig through the statistics, dig through the logs, dig through whatever is available and see why isn't this thing working as expected. So towards that, Postgres has quite a few virtual views that tell you various things about your database. So per function statistics, how many times a user-defined function has been executed, how long it took, etc. Performance views, you have pgstat activity. It doesn't exactly give you performance view, but it gives you an instantaneous view of what's happening in your database right now. How many queries are running, how many transactions are running, which is the longest running transaction, which is the longest running query, is the query waiting for another query to release the log, etc. If that level of information is not sufficient, you can dig down deeper into the log information using the pg_logs view. So that gives you specifically that this backend of this client has this log, and the other backend is actually requesting the same log, but it doesn't have that log. So if there is a logging affecting the performance of your applications, you can dig through that. And then there are a few other pgstat views, dynamic views like pgstat all tables, pgstat user tables, that give you the statistics of specific tables, like how many sequential scans were done on this, how many tuples were fetched, how many tuples were read versus transmitted. pgstat all indexes, similar statistics for indexes. And then you have other statistics views, like even to see the statistics of your replication, streaming replication, how far behind a replica is from my master. So all the pgstat views help you dig through the statistics numbers, the counters of database. First ways that you want to start diagnosing your problem if your queries are running slower is logmin duration statement. You simply set it to a value which says my queries are not supposed to run slower than or longer than this, and then you would have those queries logged into server logs. Dig out those queries, run those, explain, analyze those, and try to diagnose the problem why they are running slow. The other way of diagnosing your problem is log temp files. One of the first ways, or one of the most common ways queries get slow is by generating or sorting through data, and then when the sort doesn't fit into memory based on your search settings like workman, if it doesn't fit into memory, it's going to spill over to disk, and that makes the query really slow because it's orders of magnitude slower than sorting the data in memory. So log temp files gives you a way of recording whenever a temp file is created beyond a certain value, certain number of kilobytes, and if it is creating that many, you can track down which backend is creating the temp files, which queries are causing that, and you can diagnose and work backwards from there to fix those queries. Postgres also has built-in support for dtrace and system path. These are the operating system facilities that have been developed like in pretty recent years. System path is the Linux equivalent of BSD's dtrace. What this allows you to do is, on a Rust running system, without having to recompile your program, without having to inject any new libraries or anything into your running program, from the OS level, you can track which function is taking how long. You can create scripts that will track the counters of your I/O statistics, of your run times of functions, etc. And you can record the diagnostic information from those and look at which parts of the database are slow. Is that like the locking that's making you slow, a specific spin lock or specific lightweight lock, or is it my I/O that's bringing my system down? So this is a facility that doesn't require any kind of recompilation or anything. So coming on to extensibility, we have already seen examples of how extensible Postgres is, in the sense create your own custom types, create your own operator overloading, you can create your own index types, etc. So it's very highly extensible. It's just repeating the same thing that I already said. You can create your own data types, operators, index types, etc. And recently, like I think within the last couple of years, create extension is a way of clubbing those things together into a single object, into a single package that says create extension XYZ, and that XYZ in turn pulls in or creates everything that is related to that functionality. So you can package your types, you can package your tables within that, you can package your operators, and index types, etc., within the create extension mechanism and deploy them on your database. So PGXN is a website, is a initiative from David Wheeler, one of the contributors to Postgres community, who has worked on create extension, the extensibility part of Postgres, to package these things together, and people can deploy or publish their extensions on that website, and people like us can simply go ahead, download that, and execute the function create extension and get that functionality. For example, HStore used to be a built-in type. You could simply say compile it, install that SO file, install the run the SQL for doing that, etc. Now you can simply say create extension HStore and it does everything for you. You do not have to do anything that used to earlier take like many commands and many configurations to do. Foreign data wrappers allows you to query the data that resides outside your database. That data can be anything: Oracle database, another Postgres database, MySQL, or simply even the flat files that are residing on your system, or maybe even your server log files. You can query your etc password by creating foreign data wrapper. Foreign data wrapper is a way of saying these are the functions, or this is the mechanism I'm going to talk to a specific data source, and using that you can define foreign tables. Foreign tables is what you say, create foreign table XYZ, and you define how that access is going to be, and you can, after that, it simply acts as your normal table. You can query from it, you can join it, you can modify it. Modification is a recent addition. Foreign data wrappers, now with the recent version, they have the capability of pushing out the writes, updates, and inserts. Earlier, they didn't have that. So again, it's a platform. That's what we are pushing towards. It's a platform. It has everything built in. It has every capability that you want. Stellar examples of extensibility is PostGIS, like one of the very long-standing, very long-running project, and it is completely disjoint from Postgres development. Postgres version 9.2, 9.3 does not mandate that there will be a different version of PostGIS. PostGIS is a separate project running under GPL license. It has, like by definition, like its own statement says, it adds support for geographic objects. So you can create maps, you can perform geospatial calculations and manipulation within the database using this extension. And this extension creates its own types, line strings, polygons, etc. And then it creates operators to use on top of them. Postgres HLL, it's been covered in one of the talks in this conference. It's a unique extension in a way. Instead of having to scan the whole table and gather the accurate number, it gives you a very close approximation of the number of uniques within the table, within a query. So another example of extension that can do various kinds of things that your database was earlier not capable of doing. And people came up with the ideas, implemented it because Postgres allows you to do that. So we are done with developer's perspective. So all those reasons were for us, for a Postgres community member to woo a developer. Why would you want to use Postgres instead of your own database, whatever you're using? Cost was one big factor. And many of those are actually in overlap with the manager's perspective. A manager cares about a lot more things than just those. Those are important because that's what their developers are going to do. But manager's perspective is a bit different. It adds a few things. So acquisition cost, again, license. What kind of license is the project under? Is this project future-proof? Is my investment future-proof? What kind of vendors or providers or supporters do I have? Do I have enough of an ecosystem to make sure my database, my project is not going to die because one provider died? Maintenance costs, recurring costs, and then buy-in from the higher management. So acquisition cost, zero. It's free. It's available. Go ahead, compile it if you want to. You have already like distributions available. You can simply install it. Just to reiterate, it's exactly free. You do not have to pay a single penny to do anything with Postgres, and you get all the features. Not one bit of Postgres features are behind a GPL license or behind a commercial license or of any kind. So you save money, a lot of money. License cost is a big cost. You have higher profit margins because of that, because you did not spend a lot of money on database acquisition. and that becomes a leg up on your competition, because your competition is probably spending millions of dollars on support costs and license costs on commercial databases. We have already covered the BSD-like license part of it, so I won't cover that. Future-proof. This project is community-driven, and specifically I use the term project, not product. This is a project that is community-driven. That means it has no single commercial entity who controls the project or its directions. What goes into the project, what features are implemented, how they're implemented, is all community-driven, is all collaborative. Unlike MySQL, if you are not aware of that, let's say 5 years ago, but now you are aware of what MySQL was and why it was not a good choice from the beginning, because it was GPL. Just yesterday I read Monty Python's quote somewhere in one of the articles. He said that was one of the biggest mistakes I did. When I sold it to Sun, I should have said it would be GPL for 3 years and then it would turn into BSD, because BSD gives a lot more freedom to the community, and it does not give a single point of control to the company who owns it. So MySQL AD sold it to one company, and finally it now is bought by another company who everybody fears. Now they want to get out of it. Now there's an alternative called MariaDB. Thankfully, there is an alternative. But still, it's community driven, not controlled by any single company. That means you are safe. You will not be twisted to pay any kind of money in future. It will always be free from the cost perspective and project management perspective. Project is not managed by a company. The cost you will not have to ever pay for that. In terms of future proofing, this is a graph that displays or that depicts the growth in number of jobs that require Postgres. The blue line is MySQL, the orange line is Postgres, and this is percentage growth. At this point, MySQL requirements or the needs of number of MySQL jobs is still 10 times higher, at least 8 to 10 times higher than Postgres jobs. But this depicts since January of 06, the percentage increase of jobs. So it has increased by 2,250% since over the last 7 or 8 years. So that gives you an idea of the ecosystem that is growing around this project. It's not just a few people working on the project using in their product. It's not the case anymore. Now it has actually grown into an ecosystem. You have vendors and providers, not one, not two, but many. And when I say many, there are many. So Enterprise DB I work for, so I had to put that name at the top. So yeah, so I can put it anywhere else, yeah. So we are a big supporter of Postgres. We have many core committers. We have many ways of contributing to the community. We build the installers for various distributions. So that's one way we contribute to it. But then apart from us, there are PG experts, second quadrant, OmniTI, command prompt, and I'm sure I'm forgetting at least 2 more major companies who support or who provide support for Postgres. And apart from these big name companies, there are consulting companies, smaller jobs, smaller shops, individual people who support, who specialize in Postgres, but they do not work for a special company. They are available for taking too. So if you have a requirement of a Postgres DBA support or somebody who you want to come in and check your database or development, you have availability. Maintenance cost, you have 24/7 support available. Every company, every database would provide you that, but Postgres support is very cheap when compared to your commercial database companies. You pay millions of dollars for support to bigger companies. I do not know the cost from the other companies. I'm pretty sure they are very low too. But I know about my company, we charge I think $4,000 or $5,000 per socket, not per core, just per socket. It doesn't matter whether that socket has 4 cores, 2 cores, or 8 cores. So that's the level of economy that you get when you go for Postgres and you have cheaper support contracts, and that's like treating you like premium customers. Maintenance cost, you have constant needs of consulting a DBA or a remote DBA. If you cannot hire a DBA right out, you can hire a remote DBA You can have somebody come in and perform database health check. You can have training for your DBAs and your developers. That improves the uptake of Postgres within your company. And this is the last slide, upper management buy-in. If you want to convince anybody above you, you are a developer, middle-level manager, top-level manager, if you want to convince your rest of the company to say, do I want to use Postgres versus whatever we are considering right now, just show them these slides. The cost advantage is one of the biggest things that I would say that would attract the company to take Postgres, but then consider the other factors too. It's an enterprise level database with exactly equal performance, a lot more features, and extensibility. That makes the case for a platform that you want to buy and lock in, not lock into, avoid the lock-in, and still survive the next phase of economy bubble or economy downturn.